Hello everyone, today we are getting into section 5.5, the trapezoidal rule. Again, this is taking us back to approximations. We want to approximate the area bounded by this curve and the x-axis from x equals 1 to x equals 2. So our curve is y equals x squared plus 1. So when you go to graph this, notice how I counted here. Every two blocks I numbered as 1, so this helps us sort of spread this out a little bit better. Now, even though we really just need the area from x equals 1 to x equals 2, I'm going to spread this out and graph a few more points just to help me graph this as accurately as possible. So what we're going to do is just draw our vertical lines going down, but now instead of making rectangular approximations, you're going to see how much more accurate this is. We can just make one. We're just doing one trapezoid in this case. And we want to find this area. So if you notice, it does, at least in my sketch, it does go over the graph a little bit. But again, we just want to calculate this area. So we would say the area is approximately 1/2. Remember, formula for area of a trapezoid is 1/2 the height, so the height is just 1, times the sum of the two bases. So our first base reaches up to 2, our second one up to 5. So we could say the area under the curve here is approximately 7/2 square units. Now, even though we know how to find the exact area now, the AP exam loves questions involving the trapezoidal rule. Now let's do the same problem, but let's use two trapezoids. So that means I need a little subinterval in here. This will just be 3/2. So we're going to go up to that point on the graph, right about there. We'll figure out what that ordered pair is. We'll create two trapezoids here. So we'll say the area is approximately 1/2. Now the width of the height of the trapezoid is just going to be 1/2. And then the sum of the two bases, we still have a height here of 2. But again, if y is equal to x squared plus 1, and we square 3/2 plus 1, so that's 9/4 plus 4/4, which will give us 13/4. So this is 13/4 here. And then it's plus 1/2, so the area of the second trapezoid. Again, the width or the height of the trapezoid is 1/2, and then it's 13/4, and then we finally reach up to the 5. So we can say it's 1/4, and we'll have 21/4 plus 1/4 times 33/4. So we get 21/16 plus 33/16, which is 54/16, or 27/8, which turns out to be about 3.375 square units. So the first gave us 3.5 square units. The more trapezoids we use, ideally we should get closer to the exact area. So it looks like the first one definitely wasn't over approximate. We're getting a little bit closer. Now we're going to try this one more time with 4 trapezoids. So let's definitely space out our x values even more. In this case, I'm going to count every 4 blocks will count as 1. So that means I need these 4 subintervals here, and we'll figure out the ordered pairs in a second. So here's our first trapezoid. Here's our second. So you definitely see the advantage over the rectangular approximations. So now the height of each trapezoid is going to be what? 1/4. So right here we'll have 5/4, 6/4, 7/4. So the ordered pairs here, so we'll have the heights are second bases or the first bases of one trapezoid as a second base of another one. So we'll have 5/4. If we squared that, that's 25/16, and added 16/16 or 1 to it, we get 41/16. We're at 6/4, the 3 halves. We already said that that's 13/4 from the previous example. And then if we have 7/4, it's 49/16 plus 16/16 gives us 65/16. So this is going to help with our calculations. So I'm just going to scroll down a little bit here right underneath. So the area is approximately, we'll have 1/4. I'm sorry, start off with 1/2 times 1/4. Again, our first base is 2 plus the 41/16. It's the height of our second base. And then we'll have plus 1/2 times 1/4. Our first base of the second trapezoid is the 41/16. And then the next will be the 13/4. 1/2 times 1/4. Next, we'll start with the 13/4 plus the 65/16. And then our last 1/2 times 1/4, which just kind of squeeze this in here, the 65/16, and then plus the 5. Now, if you notice, there's quite a few common factors for each part. So we could say the area is approximately, we could take out the 1/8, right? And then if you notice, just our very first number 2 and the very last number 5, those are the only two that don't repeat. So we could say 2 plus, we've got 2 41/16. We've got 2 13/4, and we have 2 65/16. So it's less numbers if we write it this way. Then we have to still have the plus 5. Now for this, you could go ahead and type this in on your calculator. Pause the video if you need more time. This should give us 107 30 square units, which should be even more accurate. So this actually turns out to be 3.344 square units. And the actual area is actually equal to 3 1/3 square units. So even more accurate than what we were looking at with rectangular approximations. So we're now going to generalize this trapezoidal rule. And this is used for n trapezoids. So the area, still an approximation, is 1/2 the height times our first y values. We're going to say this is y0 plus, we should have use 2 of our second y values, plus 2 times y sub 2 plus, and then we keep going to 2 times y sub n minus 1. And then our very last y value just shows up once. But again, this is only going to work when the heights of the trapezoids are constant or the same. This is only used when h is constant. Now, most of the time, the problems in AP exam and what I'm going to give you soon enough in your textbook, they don't actually have you graph that because we know now how to find the exact area using integrals. Rather, they may give you a table like this and ask you to find a certain area, find a certain value, see if we can use a trapezoidal rule. Remember, we can only use this when the spaces, the distances between the x's are the same. So can we use this here? The answer would be no. We could still create trapezoids, we just can't use the simplified version, the trapezoidal rule that we came up with. We would have to find the area of each trapezoid individually. So in this case, we can't use the trapezoidal rule because h is not constant. Our first distance is 1, then we jump up to 2, then we jump up to 4. All right, so your assignment on page 295, please complete numbers 2 through 5, parts A through D, and number 7. Now the part D should be written in the book, but we're looking for the percent error. And the calculation here is you just take your experimental minus the actual, so your approximation minus the actual, divided by the actual, and then multiply it by 100. Then some more AP practice problems for you. All right, just let me know if you guys have any questions.